Hello friends, in today's question, a block of mass m to 1 kg slides with a velocity v 6 meter per second on a frictionless horizontal surface and collides with a uniform vertical rod and sticks to it as shown. The rod is pivoted about O and swings as a result of the collision, making an angle theta before momentarily coming to rest. If the rod has a mass m, that is 2 kg, and length L 1 meter, then the value of theta approximately is. So this is object m moving with the velocity v. It strikes the rod, which is going to pivot about point O and sticks to the rod and making an angle theta before it comes to stop. The mass of this rod is given as capital M and length is given as L. So in this case, we are supposed to find out what will be the value of theta. So we are going to use first of all the conservation of angular momentum about point O. You can say conservation of angular momentum about point O. So means initial angular momentum will be equal to final angular momentum. Initial angular momentum will be equal to final angular momentum. So let's first of all find out the initial angular momentum. Initial angular momentum, as rod is stationary, the only momentum will be present will be as soon as it strikes the rod. Okay, that will be your m, v and L, and please bear in mind it will be pivoting about this axis O prime. Okay. So this we have a initial angular momentum and the final angular momentum. And we say that it is pivoting about the x-axis with the velocity of angular omega. So we are going to have angular momentum because of the mass m and angular momentum because of the rod as well as mass. So we get final angular momentum will be equal to the angular momentum ml square plus 1 by 3 ml square multiplied by angular velocity omega. And 1 second, this is capital M, mass of the rod. Okay, so first part is because of the angular momentum because of the mass m, and angular momentum because of the rod is 1 by 3 ml square multiplied by omega, that is the angular velocity. So here I can say this ml square is angular momentum due to mass m and 1 by 3 ml square is angular momentum due to rod. And obviously it will be multiplied by omega, and this will be also multiplied by angular velocity omega. So now we are going to substitute it initial into final. So we are going to get this as mvl is equal to ml square plus 1 by 3 capital ML square multiplied by omega, and L and this L cancels out, so we get this as omega is equal to, this will be 3 mv divided by 3 ml plus capital M multiplied by L. Substitute value, this is 3, small m is given as 1, velocity is given as 6, divided by 3, and small m is 1, length is L, plus capital mass is given as 2, length is L. So this becomes 18, and this will be equal to 5. So this is our angular velocity. So we are going to use later on. Now we are going to use the conservation of energy in order to solve it. You can say conservation of energy. So we can say initial energy after collision, just after collision, okay, just after collision will be equal to final energy at maximum height. So let us first of all find out the initial energy. Initial energy just after collision will be equal to half moment of inertia of the, let us call the system, that is total, multiplied by omega square. And let's find out the moment of inertia of total moment of inertia. So we can say I total will be equal to moment of inertia of the rod plus moment of inertia of the block. So we get this as 1 by 3, rod is capital M square plus ML square for the block. We substitute the value, we get I total is equal to 1 by 3, mass is 2 kg, length is 1 square plus mass small block is 1 and 1 square, and this will be coming as 5 by 3. So we already know value of omega square, so we can find out that initial energy will be equal to half multiplied by 5 by 3 and multiply by 18 by 5 whole square. This will be coming as 10.8 joules. And now we are going to add final energy at the maximum height. Final energy at maximum height will be equal to, now the final energy will be because of the energy, because of the mass, okay, and this will be the potential energy, okay. Final energy at maximum height is nothing but potential energy, so which will be equal to potential energy because of the mass m plus potential energy because of the rod. So let me draw the figure. So initially rod was in the vertical position, and this is the final position of the rod, that is angle theta, and we have a block here. So block, let us suppose, is at a height of h. Okay. So this is a block of mass m. So we can say potential energy of mass m will be equal to mgh, and let's calculate what will be our h. So this total length is given as capital L, okay, and this length will be also, sorry, capital L, small l. So this is point O. So we are going to get this as L cos of theta. So from here we can say H will be equal to L minus L cos of theta. So we get this as potential energy for mass m will be equal to mg. L can be taken as common, so this will be 1 minus cos of theta. And let's find out potential energy for the rod. Potential energy for the rod. And let me draw the figure again. This is point O, and this is angle theta. So we have total length L, and as the mass is uniformly distributed, so let us suppose this is the center of mass, and its length will be L by 2. So this length will be coming as L by 2 cos of theta. So let us suppose this height is HOCM, center of mass. So therefore we can say that height of center of mass will be equal to L minus L by 2 cos of theta. For the, we can say, potential energy for the rod, let me redraw the figure again. So this is our initial position of the rod, and this is the final position with angle of theta, and initially, and the total length is given as L. So center of mass is supposed somewhere here. So the center of mass distance from point O will be equal to L by 2. Now, as it moves from the mean position to the final position, let us suppose the center of mass is now here, and this distance length will be our also L by 2. Now, initial position of center of mass is this one, and this is the final position. So we have to find out by how much amount the center of mass has risen. Okay, so you can say this is center of mass initial, and this is center of mass final. So this angle is theta. So therefore this height will be coming as L by 2 cos of theta. And let us say this is given as the height through which the center of mass moves is HCOM. Therefore, we can write that our height of center of mass is equal to L by 2 minus L by 2 cos of theta. So total height initial is center of mass is L by 2, and the final height of this vertical height, okay, is L by 2 cos of theta. So height with the center of mass which moves is HCUM. So we can say HCUM, taking L by 2 as common, it will be 1 minus cos of theta. Therefore, we can say the potential energy of the rod will be equal to mg, h center of mass will be equal to mg, and we have this L by 2 1 minus cos of theta. Therefore, the final energy is equal to potential energy of the mass m, that is mgl 1 minus cos of theta, plus potential energy for the rod, which is our mg L by 2 1 minus cos of theta. Okay. Now we can just rearrange this. We are going to get this as GL 1 minus cos of theta is common, so we get m, plus for the rod this is capital M. Okay, so we can say this will be m by 2. Now we are going to simply substitute the values. We already know the values. G is said to be taken as 10, so this becomes 10 multiplied by length is 1, so 1 minus cos of theta. Mass of the small m is given as 1, and the mass of the rod is given as 2, so this will be 2 by 2. So m goes with m, 2 cancels with 2, this will be 1 plus 1, so we are going to get this as 21 minus cos of theta. So we found out the initial energy as well as final energy. So we are going to put initial energy and final energy in this equation. Therefore, 10.8 is equal to 21 minus cos of theta, or we can say from here 1 minus cos of theta will be equal to 10.8 divided by 20, which will be coming 0.54, and cos of theta is equal to 1 minus 0.54 will be equal to 0.46. Therefore, theta will be equal to cos inverse 0.46, and which will be equal to 62.61. So theta can be approximated as 63 degree. So this is the value of theta. This is the value of theta. Therefore, we check the option available to us. Option number A is the correct option. You can say option A is correct. So this completes the question. Thank you.